you have any questions, videos have been uploaded. I have also, will be uploading this video that we're making right now. I'll be also uploading some answer keys for you guys to help you all if you have any questions. Besides that, how's everybody feeling?
Horrible.
How's everybody feeling about the quiz tomorrow?
This is the first one to actually feel.
Tomorrow's Friday?
Yeah.
Yeah, today's Thursday, which means tomorrow's Friday.
Oh, man.
Oh, wasn't here like Monday, Wednesday,
So in this, remember what I said, don't just think about the mathematical part of this. You also need to think of the conceptual stuff. Also remember what I've said. Once you learn it, don't forget it. All is fair game.
When's your planning?
My planning is 7. I probably won't be in here. I need to install a printer for a teacher.
Ooh, you found the printers.
I did. I'm not installing one of those printers though.
Yeah, where'd you find the printers?
They were literally that day they were put away by Mr. Stewart in a computer lab storage that I don't have access to.
Printer band that didn't
Huh? Look at this one. Alright, so in this, today we're going to talk about something very, very exciting. Yesterday, remember what we discussed and talked about? All about light and electromagnetic radiation being what? We talked about being a wave. What did we talk about it with being a wave?
It's also a part.
Yeah, it also is a particle. What did we talk about yesterday? It is both. What did we talk about yesterday?
The press.
I don't recall us ever talking about the pressure. Maybe because this isn't a health class.
Football team. There will be no practice at all this evening, no film watching, no practice. However, at some point, probably around 7:30, you will be called to Mr. Halsey's room to get your jersey.
Did you have to do that any after-school tutoring or practices, anything after school is discouraged today because of the weather that's coming through. So if you have anything planned as far as practice or after-school tutoring, please consider changing that plan for today. Thank you.
If they let us out early, I will scratch.
I don't think they will. What's supposed to be? It's just gonna be rain.
It's supposed to be like 20 or 30 miles per hour wind.
Oh, yeah, it's in the phone.
I think I'm going to take some on the county for safety precautions.
Yeah, we don't feel safe here.
For safety
Is it like 22 miles per hour?
Alright, we gotta get stuff covered. I don't know. It's all news to me.
because they're canceling practice.
So in this, we talked all about how light was a wave. And we ended yesterday off talking about light being a particle. So, electromagnetic radiation is a particle. So today we're going to start this little journey. And this journey has a purpose. Its purpose is to first educate you. Secondly, it's an exciting journey because today your mind starts getting a little flabbergasted a little bit because you're like, wait a minute, how can that, but then how, when, what, huh? Well, okay. Y'all gonna make it over there? Also remember that your lab reports, they are due to me tomorrow. That is the first submission deadline. Alright, so in this, what proof light equal particle? I'm surprised I have not heard from Miss Steffi yet. Somebody took a picture earlier and said they were going to go show her. I said, go right ahead. So in this, just like we did yesterday, we're going to start talking about what gave proof that light is a particle. Okay, we proved yesterday, we talked about the experiment, talked about the person that did it, and we explained the experiment down. Today we're going to talk about what all led us to knowing that light is a particle. Electromagnetic radiation is a particle. Now in this, there was the Mad Daddy scientist, top dog, easy guess.
The dude you talked about yesterday.
No. Albert Einstein.
I said Einstein yesterday.
I didn't hear it.
I said Einstein yesterday, Thomas Young. What's wrong with me?
So Albert Einstein is the one that did this. Now this is the key. The proof is in what he got his Nobel Prize for. Does anybody know what Albert Einstein received his Nobel Prize for? Okay, it's Albert Einstein's photoelectric effect. This is what gives proof that electromagnetic radiation is a particle. And this is kind of the premise of how it went. Now please understand, I'm not going step by step and using the information that he used, but I'm getting the premise of it and bringing it to your level so that you can understand it. So in this, let's say we have a piece of metal. Here's our metal. And for simplistic purposes, let's just say aluminum, because you all have used aluminum, you've seen aluminum, you've dealt with aluminum in some form, way, and fashion before. So in this, with this aluminum, Albert Einstein had an idea to see what would take place. He decided to take different sources of electromagnetic radiation and fire it at, or shine it on, that piece of metal. So in this case, let's say we had something red. If I took a red light and shined it on a piece of metal. Well, to our surprise, nothing happens. That's sarcastic. We don't expect nothing to happen. But then let's say, for example, life gets interesting. Ladies and gentlemen, it gets interesting because let's say you decide to kick this thing up a notch. Let's go from red and then let's get something that's got more energy to it. So let's move from visible light. And I don't want to use gamma rays because that's dangerous to me. That could kill me. Well, why not? Let's just do something like X-rays. So these X-rays pop in here and hit this aluminum sheet. Now the key to this is this metal. You have to understand, you're going to learn later on in this class about metals, and metals will form something we call metallic bonds.
Mr. Hall?
Yes.
Molly McKinney is needed in the kitchen.
She's on her way.
Thanks.
My mom was there, I was crying, and she believed me, and came back here. And I just texted her and said I was not crying. She said, you said you was. There I go, that's right.
Have fun. So in this,
She's like, oh my God.
this aluminum has a sea of electrons. Within the sea of electrons, these electrons are just freely sitting there. They literally just give the electrons up. They're just hanging around. And this is the interesting thing that takes place. The X-ray comes in, and all of a sudden, pop. Off comes this electron. So electrons start to come off. So they'll pop off here. And that's interesting. If I wanted to move my water bottle, how would I possibly be able to move my water bottle? Okay, pick it up. And what did I pick it up with? Okay, what would you classify my hand as? A wave or a particle? So particles can interact with each other, right? Okay, if I used a wave, would it pick up my water bottle?
It's a water wave. Like a wave.
Now, telekinesis, that works.
Yeah, that too. I mean,
I think it depends.
I don't think you like really move it.
If I was firing sound waves at my water bottle, was it going to move?
You scared enough,
it
it might
could
get up.
if they were strong enough.
I'm not gonna.
It causes the water. It
No!
causes the water to vibrate.
Waves will not make it move.
It was worth a shot.
So there's the waves in the water right now if you hear it.
So here's the interesting thing we got. What are X-rays? Wave or particles? Waves. What's electrons?
Particles.
Particles. I'm so happy y'all said that because I'm pretty sure it's like me. Took us a little bit to get there. Second period. To be more accurate, they are subatomic particles. In this, if you wanted to be extremely accurate, you could say negatively charged subatomic particles. Right now we don't care about the charge. We care that the fact that it's a particle, and out of nowhere, a wave is coming in and popping a particle out. How is that possible? How is that even feasible? How can something that's a wave pop in here and kick a particle out? This is happening because there has got to be a particle in there. So within this X-ray coming in shoots an electron out, proves that there is particles within electromagnetic radiation. So, the photoelectric effect proves electromagnetic radiation is a particle. Now hold up. Ain't that interesting? You have proof now that electromagnetic radiation is a particle. Well, yesterday we went through proof that proves that electromagnetic radiation is waves. But you can't have something to be one thing but then be another thing. It's stuck down to one or the other. In this case, it's not true. You find yourself stuck with it's both waves and particles. And this is a particle that you've heard of before. Does anybody want to take a shot at what these particles are called?
This is very simple.
Very simple.
Just wait.
No.
Are we filming?
Yes, we're filming.
Oh, man.
She just spelled it.
Photons!
I wanted to say that.
You did know it.
That's exactly what I meant to say. Gosh, Mr. Hall.
Yeah.
I was so close.
Okay, remember when I'm writing these things down, I'm writing them down for you in terms so that you can like get an understanding of what these are. So photons are particles of electromagnetic radiation
I'll abbreviate that to ER.
that stands for endoplasmic reticulum or emergency room. But hey, if you want to go ahead. No, I'm fine with that. You can do it. That's totally fine. On your notes, guys, your notes is your notes. As long as you know what it stands for or mean, it's fine. I'm not gonna, honestly, I'm not gonna come here and look and make sure you're taking notes, because the truth of it is, if you're not taking notes in this class is not gonna go well for you. So, electromagnetic radiation, that has a quanta
A what?
of energy and no mass.
What is quanta?
Quanta is like a quantity. It's a certain value. It's a certain amount. But we use quanta because it's going to be fancy later on. I'm going to let you guys know. You're going to learn in this class the foundation and the basis for everything that's quantum. Quantum mechanics.
Quantum physics.
Everything comes off these base ideas. It's very exciting. I know. It's thrilling.
Woo.
I need y'all to like turn your excitement down a couple notches. So in this, I want to talk about this idea just a little bit. So within this, we find ourselves talking about photoelectric effect. You really need to know what this is. So the photoelectric effect. First and foremost, photoelectric effect proves electromagnetic radiation is a particle. And try to put this in terms where it makes sense to you so you're not like all covered up and confused, because the truth of it is my goal is not to use big scientific terms to where you look and go, oh my gosh, Mr. Hall is so smart and you have no idea what I'm talking about. The goal is for you to understand what I'm talking about. Not to walk out of here and say, I have no idea what those words were. So in this, let's say what the photoelectric effect really is. It does not depend on the intensity of the source of electromagnetic radiation. What matters is, bless you,
Thank you.
the amount of energy the photon is carrying. What's truly, really mattering in here is all about how much energy is in that photon. It's exactly what matters. Nothing else matters. If red light is shined on a piece of metal and electrons are not firing off from it, it doesn't matter if I use radio waves. these are not going to fire off these electrons. Okay? It's all about the energy source. If X-rays are throwing it off, I can use gamma rays and we'll kick some electrons off. Get it? With me saying this, we are recording, and this is to be used as evidence if any of my students go home and do what I'm about to use as an example in this classroom. I am not giving any permission to any student in this room right now to go home and do this. I'm not directing them to do this. I am telling you not to do this. Parents that are going to see this know that I'm not telling you. I'm using it as an example. So don't do this. If you want to know all about this, then stop this video, search it up on YouTube, pretty nice video of it. How many of you have ever seen a piece of metal in a microwave and it turned on?
Huh?
No, you can't put it in the microwave.
Don't that like blow the microwave up?
It will destroy the microwave, which is why I'm telling you not to do it.
Let's go home and do it.
Yeah.
Okay. Did your parents know you did this?
It was my brother.
Oh, okay.
Yeah. We blame a lot on him.
Yeah.
So, did you see the sparks and everything firing off from it? All the nice little display? Yeah, hopefully you were like, oh snap, and you stopped it real quick.
It was a slush.
That right there is the photoelectric effect happening. What's happening is that energy
It was like
from those microwaves are jumping in, hitting the metal, and firing off these electrons.
Let's just say we had to get a new microwave because you know those like slush puppy things that you get at the store that are like in a kind of like a metal.
Oh
thing?
yeah.
You put those in the microwave and it kind of like blew up.
Why do you put that in the microwave?
Because he was like 6 at the time and didn't know any better. So now we make fun of him for it.
That's an example. And we're not out to attempt that, by the way.
So it is a science experiment. We buy a cheap microwave and do it.
Yeah.
Y'all buy it, bring it in, we'll do it.
For real?
Addie will bring it.
I'll for real bring one in.
I'm recording this, so yes, if you go and get a microwave and you give me permission, you bought it, your parents bought it,
We don't care. Let's just blow something up.
you better check with your parents to make sure they're okay with you blowing up the
Everybody
microwave.
says give $5 to the charity
We
fund.
ask
of a
for forgiveness,
microwave.
not for permission, Mr. Hall.
Yeah.
That is y'all's problem. It ain't really mine. If they bring it in here, I'm gonna look and say, yo, I got it on video that they were supposed to ask permission before doing this.
That was our motto last year.
Let's don't say we did.
Yeah. I'm down.
I'll call your parents before we blow
If we
up.
find a random microwave, we can do it.
Let's do it in like the. Oh crap.
I'm sure I can do one up somewhere.
Mr. Hall.
Yeah. Plug it in an apple, Hannah.
All right. So in this idea comes up, and this is the idea that I love. And I love getting to this point and really getting to talk about it because now chemistry is getting exciting, chemistry is getting fun. We get to talk about, you learned about light and electromagnetic radiation being a wave. What proved electromagnetic radiation as a wave?
Photoelectric effect.
Nope. That proved it's a particle.
Oh, well, what's the answer?
The double slit experiment. Who was it that did the double slit experiment? Thomas Young. How did it prove that electromagnetic radiation is a wave? What was the key?
The crest and the crest matrix. Interference pattern.
Interference pattern shown on the back. Why? Because it's a quality of waves. Particles will not create interference patterns. They only create by waves. Crest and crest meet. What happened? You brought it up. I thought it would be a good talk.
Do they interact?
crest to crest meet up, they do not cancel out, they'll amplify. So you see the bright fringes on the interference pattern. Trough and crest meet, what happened? They make the darker fringes, the areas where they're getting canceled out, okay? In simplistic terms, I put on there that it was just you didn't see light. But it's the darker spots, you're right. If a trough and a trough meet, what do we see?
You see light.
You see the light. Trowel and trowel meet. You'll see the light.
Let's take this.
Watch the video.
We can get one for $39.99 at Walmart.
I'm down.
Well, you get off your phone and worry about the notes.
I got the notes.
Well, Lisa, we
Come
can
back, I got all
multitask.
the notes.
So, this all gave proof that electromagnetic radiation is a wave. What gave proof that electromagnetic radiation is a particle?
The photoelectric effect.
The photoelectric effect. Who performed the photoelectric effect?
Einstein.
Albert Einstein. The paper was released in 1905. And surprisingly, you would have thought he would have got the Nobel Prize for his theory of...
I'm pressing the off button. Turn it off.
You would have thought Albert Einstein would have got it for his theory on relativity, but he never did. He actually got it because of the photoelectric effect, which is really cool. But it makes sense when you look at it because they spent all this time questioning is light a wave or a particle, and it has qualities of both.
Change the channel.
So in this, what are these particles of electromagnetic radiation called?
Put on Bill Nye.
What are the particles of electromagnetic radiation called? No.
Photons.
Photons.
Tell me if you can see it on there.
Yeah.
And we'll be back for this brief message.
Which both of this brings us into an era that gets us into something we call wave-particle duality. All wave-particle duality is all about all it says is states that electromagnetic radiation exists as both a wave and a particle. That's what it's all about. This will come back, and whenever it comes back, everybody goes nuts, fries your brains. It's okay. Hopefully your brains are not feeling fried at this point.
I'm already lost.
Mine's fried from yesterday.
We're even here.
I was at 12 hours taking a physical for National Guard.
Congratulations.
So that's why my brain's fried.
So in this wave particle duality, there's a relationship happening within it. Okay? With this wave particle duality, we find something special taking place.
Too much people.
Need to make sure I don't forget something. Yeah.
Were you serious about the microwave?
If y'all have permission and you bring in a microwave, we'll stick a piece of metal in there and turn it on.
So who do we have to ask?
Walmart,
Huh?
pick it up Saturday at MacArthur.
I haven't met him.
I was accepted in the college too.
Okay, can we go like out in the field?
I will go
and then blow
Saturday
it up?
and pick it up.
Like go out on the like football field or something?
Like an extension
All right.
in the middle of the field.
So in this, jumping off this wave particle duality brings us into something, and I have a question. Have you guys ever seen a model of an atom? And it looks something like this. Really? That's shocking.
Yeah.
Have you ever seen a model of an atom like this?
Yes.
Now, hopefully you've seen within these, which I doubt you have, but you've probably seen, hopefully you've seen this representation.
The only thing we ever learned from for short.
Does anybody know what the rings of this actually stand for?
Electron.
Wave.
You
General
told us
area of
anatomy,
the-
I forgot.
Isn't it?
You
I
did,
thought
you
you
told
learned anatomy, really?
Yeah.
Oh, that's impressive.
No.
N stands for energy levels. Now, this is the key. This is at an atomic level, and I don't think we're going to get to cover everything I want to cover today, but these things link together with what we're talking about. These N stands for energy levels on the atomic level. Now, this is the key. How many of you love SpongeBob?
Yeah.
How many of you know about the salty spittoon?
Yeah.
How do you get into the salty spittoon?
You gotta be tough.
You gotta be tough. And that's like what these energy levels are. It's like, here's a first level of the salty spittoon, a second level of the salty spittoon, the third level of the salty spittoon. And every one of these have a different requirement. So like the first level of the salty spittoon, you've got to be able to open a ketchup bottle without running it under any water.
Will that just make it more slick?
No, it heats it up.
Pressure,
I've never heard of that.
it's a gas law, gas thing, and we'll work. Hopefully we make it there. I want to make it there this year.
Lady Junior. Get regular wing nuts and you go.
The second level of the salty spittoon is the part where you gotta have muscles on your muscles. So the first level of the salty spittoon, you gotta have like 10 joules of energy to break into that bad boy.
So eating nails for breakfast with no milk.
That's level 7. We ain't even talking about the 7th level yet. We ain't that tough yet. So the second level, whenever you got your muscles on your muscles, you're looking somewhere about having to have 25 joules of energy. Now these numbers actually are not true representation of these energy levels. I'm just using them as an example to talk about and discuss what's happening here. So within this third energy level, this one is where you've got to have muscles on your eyeballs. Only the toughest of the tough can get into that. And in this, you find you got to have like 32 joules of energy. Now this is why this all matters. Awesome, baby girl. If you want to get out, love you. She's got a dentist appointment. So within this, we get to talk about one of my favorite things. And this is so exciting. Because there's any standard classroom you go into is prepared and ready to show you a demonstration of how these energy levels work. So this is what's taking place. You have electrons around on these energy levels. If we want to be, if we have an electron, let's say I'm that electron.
Wow.
Alright? So at this point right here in the salty spittoon, I've opened the bottle of ketchup. Okay? That's kind of equivalent to me getting up to the first energy level.
It's gonna stand. Oh, I don't heard about this.
Oh, I almost fell.
Don't do that.
I just got carried.
That'll be a meme like somebody else.
I would not upload this video if I fall. Alright, so on this, I'm on the first level at the softest spittoon. Alright, so I got how much energy?
10
10 joules. Now, let's say I want to get to the second level of the softest spittoon. I gotta have muscles on my muscles, right?
On the desk.
How much energy must I have?
25.
If I only have 24.9,
You're still in the first
hold on a
place.
second,
What?
out of brace. If I only get 24.9, can I get there?
No.
I can only get right here, so can I get to the second energy level?
No.
No, I'm stuck in the first. But if something happens, I don't care. But if something happens, and I get, let's say 27 joules of energy, can I get to the second level of the salty spittoon?
Yeah.
So I can jump up here.
On the desk.
Alright, now I got muscles on my muscles. So, if I want to get to the third level of the salty spittoon,
On the other desk.
Here he goes.
how much energy I gotta have?
32.
32. I know y'all over here can't see that. I know I'm fat and you can't see. Stop that. So in this, man, there's dust up there.
Not for elephants.
Man, you should see it. It's pretty nasty up there. Somebody should dust that. So in this case, if I only have 31 joules of energy, I can get to here. Y'all really can't see that. Don't touch my stuff. I see you looking at my stuff. Don't you touch it. Watching you. That's my wife. She texts me back. Don't tell her I did this. So if I can only get 31 joules of energy, I can get to here, right? Hey, Christy. So I can get to here, right?
Yeah.
But can I get to the third energy level?
No.
No. But if I get 32 joules of energy,
You can jump
what can I do? I ain't going to jump. I mean, I'm at a pretty high height right now. I'm going to step up here.
He jumps, he probably hits it. Spring
There we go.
He's stepping in the sink.
Wow. That's exactly what we're doing, Christy. This is what happens, people, when you're not in chemistry class. I hope the kids are enjoying and having a wonderful time, Christy.
He's got muscles on his eyeballs.
Fantastic. Wonderful.
I'm gonna send this to your wife.
Awesome. Don't do it. I don't want to hear about it.
I'm gonna do it.
Will you turn her off or something? My gosh, I'm trying to teach.
Shut up, Christy. Listen.
Alright, so I'm in this third energy level. Almost fell.
Don't do that.
Alright, I'm in the third energy level. Now this is the thing. I'm up here. I'm hanging out. This is cool. I can literally see everything. I can see all your phones. Most of them are
Wow.
pointed at me. Interesting. So in this case,
Okay.
you're at the third energy level. If we go back to the first energy level, what will happen?
You'll fall.
Can I get into that first energy level with 32 joules of energy?
No.
No,
Because it'll explode.
it's not going to explode. I can't get in there. Why can I not get in there?
Because you'll have to jump a level.
Because I have too much energy stored up in me.
Strong.
So if I want to lose that energy, okay? If I want to get into that first energy level, listen to me, okay? We're almost done, literally. You got like 3 minutes, the bell's going to ring, you're done. This right here is all, it's like the end of what could be on your quiz. So in this, if I want to get back to that first energy level, how much energy must I have?
10.
So 10 joules of energy. So for me to do that,
I know.
Let's have a prayer.
Your mic is on. the discs tomorrow.
No! So if I jump off of here, what are we going to hear? What are we going to hear? Not China, no fat jokes right now, okay? What are we going to hear?
Boom.
A thump. I said thump. Alright, so listen, okay?
Don't even
Run away!
Okay. So I jumped down.
See,
You really didn't hear a thump, but man, my feet feel it. I need to wear more supportive shoes. What happened with my energy?
Appreciate
It dropped, but law of conservation of energy states energy cannot be created nor destroyed. It can only be transferred.
You transferred it to the floor.
So the energy from me jumping from the top of this demonstration table to the floor, it transferred throughout the floor. I think some's in my joints right now. So but we lost that energy out. That's what we're going to pick up next and start talking about what's happening with this relationship and all these things in here. Because these electrons can do exactly what I just did. They can get to that second level, they can get to that third level, but they can also go back. And that's when things get interesting.
Wait. If the
Bell
interlators,
would have run right then with it perfect.
if the interlators were like full of energy though, couldn't it push it